Perfect. So first of all, hello everyone. Welcome to today's Motivated Cognition meeting. We're happy to have you here, and we are excited to have Dr. Alan Castel here with us today. Alan Castel is a professor of psychology at the University of California, Los Angeles. He received his PhD from the University of Toronto. Afterwards, he did a fellowship at Washington University in St. Louis, and he has been faculty at UCLA since 2006. And Alan Castel is an expert in learning, memory, and aging, and his research focuses broadly on how adults of different ages can selectively remember important information. And so he and his lab conduct research with adults of different ages using a wider range of methods to examine topics such as strategic control over memory and attention, to examine how value influences memory, to examine visual attention, metacognition, and decision making, among many other topics. And so today in his talk, he will present work on memory selectivity in younger and older adults, a value-directed remembering approach. We are very excited to have you here with us today, Alan. So please join me in welcoming Alan Castel.
Thank you. Thank you for that very kind introduction. And I really appreciate the invitation from the organizers. This is definitely a talk series I've enjoyed in the past, so it's nice to be here. Today, I'd like to talk to you really about my program of research and then some new studies we've done towards the end, and really give you an overview of this line of work that's looking at memory selectivity in younger and relatively healthy older adults, specifically looking at how value or reward guides what we remember. So today, like most talks, I'll remind you, I'll probably tell you more than you can possibly or even want to remember. And this is kind of an illustration of how memory works and really an overview of this program of research as well, that often we're presented with more information than we can possibly remember. And really our job is to selectively and strategically remember what's important. And what's important often depends on your perspective and who you are and your goals. So this is relevant for students who are studying for a test or an exam, older adults who might be struggling to remember vast amounts of information, really lifelong learners, people who are listening to podcasts. How do we decide what's important to remember? And then how do we strategically remember as much as we can without forgetting things that are critical? And, you know, anytime you tell people you study memory and aging, people will say, well, the one thing I really struggle with are names. And this is a very common example that people feel that is very specific to them, in fact, that they'll say, look, I can remember all sorts of random facts, but then I see someone I know well and I just struggle with their name. And I tell people, you know, that's definitely a normal aspect of memory. It's information overload, it's interference. There's a variety of reasons why this happens, that names are arbitrary and not very familiar. And then they become familiar and then they aren't unique anymore. But I think from a social psychology standpoint, it's interesting that most people say they're worse than average when recalling names, when in fact that can't be true. And so we've done some research on this kind of metacognitive aspect that people feel like they have this specific impairment. And yet older adults and people of all ages can certainly selectively remember important names. So this is, again, just another little illustration of deciding what's important. And I tell people, again, maybe you can't remember someone's name, but you can remember they gave an interesting research presentation, or you enjoyed their company at last year's holiday party, or it's someone you like or trust. And these are probably things that are more important to remember than just specifically remembering someone's proper name. But I feel like that's something people struggle with because they say that's important to me and yet I can't recall it. The flip side is I think we are remembering important things when we see faces again. It's nice for me to see some faces that haven't seen in a long time on the Zoom call, and it brings back like, oh, I've read their paper or I went to grad school with them, even if the name is not immediately coming to me. Um, so really this talk is going to focus on trying to figure out what's important to remember and how we then commit that to memory. And this has, I think, pedagogical value because oftentimes students are studying for tests or exams and they'll ask the instructor, what do I need to know for the test? And I struggle because I'll say, well, you need to know the important things. And they'll say, well, what's important? And that's very much the job of the learner to try and figure that out. And I think as we get older, maybe by virtue of not being able to remember as much, we are in fact better at honing in and figuring out what's important or what we need to remember. And you see this sometimes with students who will highlight, aspects of their textbook. And, I've had students who've gotten a bad grade and they'll come to me and say, look, I've read the textbook 5 times, I've made notes, and I'll look at their textbook and 80% of it is highlighted. So clearly they're struggling with figuring out kind of what's important and what isn't. So I think this value assignment becomes very important. Sometimes an instructor will say this is important, but I think as we go through, lifelong learning, we figure this out, and then value can really guide our behavior, and then later what we remember. So it's no surprise that older adults often experience changes and typically declines in memory performance. That's well documented. What I think is interesting are then kind of the adaptive strategies, whether they're compensatory or learned, that are then carried out for both encoding and trying to study kind of selectively, and then retrieval, kind of figuring out what we need to remember at a given time and how that changes as we get older. And I think one critical process is this selection process. Selection influences what information we actively process and then what we'll later remember. So I'll talk about some studies that we've done that look at this selectivity process. But I will note that when I use this term older adults, it catches a lot of different types of individuals. And most of the studies I'll talk about today are cross-sectional studies on relatively healthy older adults compared to relatively high-functioning college students at prestigious universities who are younger than 25. And so this is a kind of a weird sample, and it's probably gotten a little weirder in the last 5 years when we've relied heavily on online samples. So I just qualify that, although some of the studies I'll talk about are from labs. Anyone who does aging research is familiar with this issue, but I think there are some interesting features of it that can allow us to learn more about high-functioning aging, pathological aging. Of course, I think what's interesting about studying older adults is you often have these exceptional older adults, whether they're super agers or just outliers or case studies. And this is a whole direction I've also been interested in. And I've interviewed older adults for kind of a more popular press book that I'll plug right here. If you're interested in providing older adults with kind of, and it's not just for older adults, any age, an overview of kind of the psychology of successful aging. This is a book that combines some of these anecdotes and case studies with some relevant research on the psychology of aging. So when we talk about memory changes and most often declines in old age, I think it's striking that despite older adults, exhibiting a variety of memory challenges, older adults can still many times function very well, very effectively and efficiently. And I think one thing that helps is using value or deciding what's important. And I've seen this when I'd run older adults in our experiments, we'd say, okay, I'm going to ask you to study 80 word pairs for a later memory test. And I remember one older adult, after about 10 word pairs went by, she just turned her head to me and said, I can't remember all of them. There's too many. And at first I thought, oh no, you just have to try. But then I realized that this is just a different approach, that she's aware that there's just too many, whereas maybe a college student is like, oh, this is just like a lecture where there's too much information and I'm just going to try and remember what I can. So I thought maybe under some circumstances, older adults might actually be as good or even better than younger adults in terms of remembering what's high value and worse at remembering lower value. And of course, it's hard to conceptualize how do we determine what's high value? If you're packing for a trip, Packing your passport or your wallet or, your cell phone is incredibly important. Whereas if you forget your toothbrush or maybe your cell phone charger, you can replace these things. So that might be a more practical way of trying to prioritize what you can remember. And sadly, in the real world, we do notice our memory impairments only when we forget really important things. So if I asked you when was the last time you forgot something important, you might think, oh, I forgot, my laptop at the library. That was really, a disaster. But sadly, there's more devastating things where very intelligent but busy individuals will forget infants in the back of their car. And there's a variety of reasons this can happen. But I think it illustrates that, there are important things we need to remember in the real world, and it's our job to focus on that, especially in these really kind of critical situations. So one way we've tried to study this in the lab is to use a selectivity task where we've presented words paired with point values, and the point values indicate how important it is to remember the words. So in this case, words are paired with values ranging from 1 to 12, and 12 is the most important. 1 is the least important, and we tell participants their job or their task is to maximize the score, which is the sum of the point values of recalled words. So you're not going to be able to remember all 12 words we'll present because they go by quickly, but you might learn then to be strategic and adopt kind of an approach where you realize, well, I should focus on the top 3 or 4 to get my score as high as possible. So I'll talk about this task and some results, but to give you a feel of what it is like, I'll have you run through a quick trial. Here, like I said, you'll be shown a list of words one at a time. Each word is paired with a point value ranging from 1 to 12. And your job is to remember as many words as you can to maximize your score. Now, I'll note the words are presented fairly quickly, so you won't be able to remember all of them. So if you're ready, you can play along and don't write them down. Your job is to use your own memory. Okay. Okay, so now just call out as many words as you can remember. You can say them out loud. All right, this is Zoom, so it's hard for me to see how people are performing, but if you recalled ticket, house, pizza, your score would be 12 plus 11 plus 10. Those were the 3 highest value words, and I'd say your score is 33. If you recalled a few other words like snow or guitar, that would add to your score. And so you're then given feedback. Your score is 27, 33, 17. Now we're going to do this again, different list of words, but the same reward structure. And your job, again, is to maximize your score. So now you might realize, gosh, those words went by very quickly. I couldn't remember all of them. I'm going to be more focused on the high value words. And as we can look at a few different measures here. And one is just the sheer number of words people recalled. But we can also look at the value of the words that were recalled. So this is the total point score. But what we're most interested in is the selectivity aspect. Are you recalling the highest value words? And there's a few ways we can quantify that. But first, here's some of the very raw data. These are the probability of recalling a word as a function of the point value of the word. So the point values range from 1 to 12. And these are younger college-age students and healthy older adults participating in the lab. And as you can see, both groups are sensitive to value. Both younger and older adults selectively focus on the high value words, less so on the low value words. But what's interesting and kind of striking, and especially shows up on the later lists after people have gotten a bit of practice, is that the older adults are doing as well as the younger adults. So it's like they've caught up to them for these high value words, but these age-related differences show up for the low value words. So this was a finding that we got fairly excited about, because I think anytime you see older adults doing as well as younger adults, it suggests something is going on that doesn't fit the pattern of just age-related differences in episodic memory. And then during my postdoc at Washington University in St. Louis, I was able to test some people with very early stages of Alzheimer's disease. So it's very hard to diagnose Alzheimer's disease, but there's a battery of tests that these individuals go through. And if you meet these people, you wouldn't see any kind of telltale signs, but they've been diagnosed with very early stages of Alzheimer's disease. So we compared these individuals with healthy age-matched controls, and you find kind of an interesting difference here as well. Now, certainly memory is impaired with these individuals with early stages of Alzheimer's disease in the red line. So you notice that, they're recalling fewer of the high value words, but what's kind of interesting is they're actually recalling more of these lower value words. So if you just expect there to be a memory impairment with AD, you'd expect that function to be lower. But in fact, what you find is that they're having trouble kind of selectively encoding and then retrieving the high value words, and what's coming out are some of these low value words. And that kind of fits one idea that early stages of Alzheimer's disease might not just be a memory impairment, but an attentional control issue, that you're attending to things that you don't need to remember or you don't want to remember. And then another way we can analyze these data is to look at some selectivity measures in terms of efficiency. So you could imagine two different subjects. If you recall the higher value words in your subject A, you're recalling the 12, 11, and 9. That results in a score of 32 points. But like an ideal observer, if you're recalling 3 words, you'd recall the 12, 11, 10, which would add up to 33 points. So you could say you got 32 points out of a possible 33. However, if you recalled some of the high value words and some of the lower value words, kind of behaving like subject B here, recalling the 11, the 10, the 7, and the 4, you're again achieving 32 points. But again, as an ideal observer, an ideal participant, you could have recalled the 12, 11, 10, and 9, achieving a score of 42. So we can look at your output as a function of how well you could have done. And the reason I'm showing you this is Watkins and Bloom developed this selectivity index, which I think is a neat way to compare participants' score relative to chance to an ideal score relative to chance. So I'm just going to go through a little bit of the math here. It's not that complicated because I want to show you a lifespan sample that we have using this measure. So again, subject A got 32 out of a possible 33. Chance here is 6.5 because that's just the middle between 1 and 12. And achieves a selectivity index, or SI, of 0.92. So the selectivity index can range from +1 to -1, with 0 being chance. So you can see subject A is being very selective. Subject B, on the other hand, recalling more words, but not as selective. So now 32 relative to 42, their chance score is a little bit higher, but their selectivity index is still positive, but lower. So we can now use the selectivity index to look at different groups that are going to be recalling different numbers of words. And so I'm setting all that up because I want to show you this graph, which looks at the proportion of words recalled, so the number of words people recall in the selectivity task on this left side. And then the other scale on the right side is the selectivity index, which I just explained ranges from -1 to +1, but if you're being selective, it's going to be above 0. And we tested different age groups, and this is a cross-sectional study from different labs and different locations. And so I always say that this graph took me about 10 minutes to make and about 15 years to collect all the data. So I want to go through it slowly. These children are between the ages, their reading ability, but they're between the ages of, 7 and 12. Adolescents are, 14 to 17. The younger adults are college-age students. The middle-aged adults are actually, interestingly, a control group from another study that are participating in the Alzheimer's group. And then we had the younger adults and the younger older adults who are between 60 and 80, and then the older adults who are 80 plus. So it's a really interesting sample across the lifespan, and I'll show you some of the findings. And first, just to look at the green line, this is just the proportion of words recalled, and perhaps no surprise, the younger adults are recalling the most. And that's kind of predicted based on all these findings that after middle age or after young adulthood, memory starts to decline. So that's not a surprise. But what's interesting to us is that the selectivity index follows a different pattern, and it's not tied directly to recall. In fact, it tends to grow from childhood to younger adults, and then remains fairly stable into the younger, older adults, and then starts to decline. But even the decline is not as precipitous as it might be relative to other age groups. So we then tested a group of children with different symptoms of ADHD and found that kind of consistent with this attentional control idea behind this value-directed remembering, kids with ADHD recalled just as many words as the age-matched controls, but their selectivity index was lower. And as I also mentioned, the Alzheimer's data shows also a decline in selectivity as well as a decline in memory, but the selectivity decline is quite pronounced. So I think this is a nice data set that kind of summarizes some of these age-related changes in memory guided by value, but also selectivity, which might follow a different pattern and might be related to different mechanisms. And so to summarize, there's some predictable changes in memory across the lifespan. But what is interesting is selectivity seems to be maintained in adulthood and then declines with early stages of Alzheimer's disease. And children with, and especially those with ADHD, seem to have trouble selectively attending to high-value information. So this might reflect changes in frontal lobe development, could reflect changes in strategy use. So we've tried to design some experiments to get at these sorts of potential mechanisms. And in one line of work, we've done some fMRI research to look at the brain activities involved in the strategic encoding. And this is work primarily done by Michael Cohen with my collaborators at UCLA, Jesse Rissman and Barbara Knowlton and others. And so basically, we just looked at this selectivity task in the scanner and wanted to determine if people are using some strategies. And a lot of times people report, maybe as you did, that when they're studying these high-value words, they're trying to engage in deeper elaborative processing, which is typically more semantically guided and often imagery. So it's not that just people are, rehearsing them using rote rehearsal. And we were wondering, well, that's a very effective strategy. Are healthy older adults also doing this? Because oftentimes older adults will not engage in these very effective strategies, and that can lead to memory impairments. And so we found that during the high-value word encoding, so words like ticket that were paired with 12, we found increased activity in brain regions associated with semantic processing, including prefrontal areas. So I think there's also probably a cognitive control aspect to this task. And this correlated with individual differences in selectivity. So this suggests that selectivity is mediated by engagement of semantic strategies, which subjects self-reported sometimes, but especially during the encoding of high-value words. And this is not my direct area of expertise, but I'll show you some of the neuroimaging findings. You can find here, we see similar activity peaks for the high-value words relative to the low-value words in older adults, but less diffuse in the older adults relative to the younger adults. So you can see just the levels of brain activity on the left for the younger adults are quite engaged and more focused, but older adults are still doing this. And I think that is especially important when we look at the selectivity correlation. And here, as in younger adults, we see the older adults show correlations with selectivity in regions like left hemisphere semantic processing areas. So this, to me, kind of suggests that despite older adults having memory impairments, they are engaging parts of the brain that are involved in deep, elaborative semantic encoding for high-value information. And this, I think, is important because it suggests that older adults can do this. They might just not be doing it when information is not of importance or high value. And like I said, there's probably multiple mechanisms involved. And one mechanism I think that is incredibly important, especially as we get older, is metacognition. This kind of awareness that I can't remember everything, so I'm going to selectively focus on the information that is important. And so we did a version of this task where we slowed it down and each word is presented for a longer period of time, but you have to decide if you want to bet on the word. And by betting, it means if you later recall the word that you bet on, you'll receive those points. But if you fail to recall a word that you bet on, then you'll lose those points. So for each word, you have to make that decision. Apple paired with 10 points. Well, I think I can remember that and I want the 10 points, so I'll bet on it. But if you fail to recall that, there's consequences. Just like in the real world, I say, if you're going to you tell your spouse what you need at the grocery store, and you have to get a few things. If you fail to remember some of these things, there's going to be consequences. You'll come home, you might not be able to make dinner. So it's not just remembering, it's remembering the important things. So which words would you bet on, and how many would you bet on is another issue. And so what we found here in this task, this is the average score people achieved as a function of lists. So like I said, people do this. We often have people engage in this task for many lists, in this case, 6. But the reason we do this is we want to look at task experience. We want to see if people learn after 1 or 2 lists, hey, I'm not remembering all of these words. I better be selective and focus on the high value ones. And we do give them feedback about their score. So as you can see on list 1, both younger and older adults are actually remembering a bunch of words. Their score is just not very good. So in fact, the older adults are getting a near 0 score despite recalling 3 or 4 words. The problem is they're betting on 6 or 7 words. So their metacognition is not quite tuned to the number of words they actually recall. They're overconfident. And the same with younger adults. They're achieving, a score of 12, 14. You could achieve that just by recalling 2 words, but these younger adults are recalling 6 or 7 words. What's interesting is with some task experience, both groups improve their metacognitive calibration and thus improve their score. And by the later list, we actually find, again, no age-related differences. The older adults are catching up to the younger adults, and they're doing this not by recalling more words, but by betting effectively, betting on the words that they actually remember. And I think that's probably a more achievable goal for older adults. It's not that we can magically improve memory in old age, but if older adults are aware of how much they can remember, then they'll be able to focus on that information and then maybe use other tasks like write things down or give reminders for things that aren't as important. So I think this illustrates some of the metacognitive processes involved in the value-directed remembering task. So yeah, like I said, older adults are overconfident at first, and this might be a metacognitive failure, but with task experience and feedback, both groups learn to bet appropriately, but especially the older adults. And so I think, this is probably reflecting a bunch of mechanisms, and I think relevant to this group, motivation to remember. One thing could be dopamine. That's often, when reward-based learning is based on this release of dopamine. We do know that dopamine levels tend to decline in older age. So I think this is part of the puzzle, that when you see a high value word, you're going to get some reward kind of release. However, that probably doesn't help the older adults. What's probably helping the older adults more are these strategic contributions of, oh, I know I'm not going to remember as many, so when I see that high value word, I better do something to remember it. And that's the decision component where I think there's some higher level processing where older adults are making these decisions to engage in goal-based learning. Or, you've probably had this experience even in this talk, or if you go to a conference, I've had enough. I'm just going to focus on the things I need to know and, not focus on the things I can't remember. So what do I need to know for future planning? Like, what do I need to get at the grocery store? I can't remember everything. What do I need when I'm taking these medications? And so we've looked at this in a variety of tasks. We've used this weather task that we developed where you're shown a weather forecast, but your goal here is to plan a picnic, decide what day to have, an outdoor event. And later we test people's memory for all the information in this weather forecast. Can you remember on Monday the temperature and on Thursday the probability of rain? But at the end we say, what days would you avoid planning this picnic, or what days would you choose having this picnic? And kind of fitting with the literature, older adults can't remember a lot of these details, but they're pretty good at saying, oh, avoid Wednesday for the picnic. Sunday might be a good day. So kind of remembering kind of generally what's important without remembering all of the specifics. And someone shared this slide with me. I think it's kind of interesting. Yes, there are a variety of things we do need to remember, but if we do focus on the important things, that might have some potential survival benefits maybe. And so we've examined this. You might say, well, these are just words paired with point values. It's a very specific task. We've examined this with my collaborators and graduate students, some of whom are in the room, I think. what to pack when you're taking a trip. I'll talk about some of our trivia studies, positive images versus negative images, gaining money, losing money. Imagine you're taking care of a grandchild, and here are the foods they like, but also their allergies. Can you selectively remember the allergies? Can you selectively remember important medication side effects that might have kind of important interactions? Or other things that older adults seem to be able to use schemas and care about, one of which are grocery prices. So another task we've developed to see if older adults can use their prior knowledge to remember important information is this grocery price study, where we present items paired with values. In this case, the value is how much the item cost. Now, some of the items make sense and are, market value prices, but other items don't make sense. They're unusual prices. They're inflated by, $7 to $10. And then we test people's memory, with the idea being that older adults should be better remembering kind of the values that made sense compared to these unusual prices. So if you were a participant, you'd be shown, a grocery item paired with its market value. You'd be asked to remember the price for a later test. You'd also be shown items like this, which some of the older adults are like, oh my gosh, are these like Whole Foods prices or crazy inflation? And then later when we test people, so your job now is to recall the exact price. So hopefully you can, get this price, $3.99. However, when it comes to the ice cream, you might think, oh, that was overpriced. It was 17 something or around $20. And that's very much how older adults perform. This is the recall accuracy as a function of the prices. So you can see no age-related differences for these regular priced items. So both age groups can recall the market value prices. But when you look at these unusual priced items, the ones that don't fit people's schemas, both groups do worse, but the younger adults are doing much better than the older adults. It's almost like an unrelated word pair that they can remember, whereas the older adults either don't remember, can't remember, don't want to remember. And so I think that's interesting because it shows an instance where, older adults can rely on schemas to remember new information. And then, getting at the gist versus specific representation of information and memory, we then did this task where we asked people, okay, well, can you remember the general price? So can you remember the ice cream was, around $17? So we presented items again that were underpriced, overpriced, and market value. And we asked people at the test to then recall the price, but also the value category. So if you can't remember the price exactly, you might still remember that it was underpriced or overpriced. So here are kind of 3 items for you to try. And then later, after I think we had 24 items, we test people's memory. You'd have to recall the price of the eggs, but also underpriced, overpriced, or market value. So I'll let you try that. And then the peanut butter, that we asked the exact price. We tell participants they all end in 9. And then the value category, and then the pickles. Hopefully you remember the price and then the category. And what we find again, if you look at the market value prices on the left, no age-related differences from market value. If anything, older adults are doing slightly better, kind of replicating what we found in the first study. But for the overpriced and underpriced items, the younger adults are doing better. These prices don't make sense. They're not familiar, and younger adults are just better at remembering that type of information. However, when we look at the value classification accuracy, so this is just recalling if the prices were market value, underpriced, or overpriced, no age-related differences here. Both groups are pretty good at recalling all of these value classifications. So remembering that the pickles are market value or that the eggs were underpriced. So this fits some research showing that, older adults can remember certain associations, but it's the level of specificity that might be impaired, especially in this case for things that just don't make sense. And we might have some control over the grain size or level of precision, that younger adults can access, but older adults are still operating at this more general level for things that don't make sense. However, for the market value prices, older adults are doing fairly well. So schemas play a role, and I think they dictate how we remember and misremember here. All right, and in the last part of the talk, I wanted to talk about one line of research that we've been doing more recently on curiosity. One thing about a lot of the older adults we test is they'll say they're lifelong learners. They're passionately interested in learning. That's why they're doing these studies. Einstein said, I have no special talents. I'm only passionately curious. My guess is he had some special talents, but just being interested and engaged is a really important thing to keep your brain active. So in this study, like a lot of studies now have done, we use trivia questions that have been used in other tasks that have been normed, such that they'll engage a level of curiosity that may or may not, be specific to an individual. But when something is something that you're interested in, you have this feeling of, I want to know the answer. So what was the first product to have a barcode? We asked people to rate on first rate how curious they are to know the answer, then guess the answer, then we tell them the answer, then we ask them again, how interested were they in learning that? What instrument was invented to sound like singing? Again, rate your curiosity, guess the answer, we tell you the answer. What was the first country to give women the right to vote? This is much more fun in person because I can see people kind of who's interested and who isn't. But there's individual differences. So some of these are going to be things that are interesting to you and some aren't. But what we're interested in specifically is not just the overall level of curiosity, but whether at the item level, are you going to remember the things that you're interested in that engage that level of curiosity? So the first product to have a barcode, anyone want to venture a guess? I probably can't see the chat or Zoom, but it was Wrigley's chewing gum. What instrument was invented to sound like singing? Maybe violin. First country to give women the right to vote. This is kind of an interesting one. It was New Zealand. All right. And so what we then did is called people a week later, asked them these same questions again. And what was interesting is older adults showed a stronger correlation between their curiosity and post-answer interest and memory relative to younger adults. So older adults are basically remembering the ones they thought were interesting, whereas younger adults don't show as much of a relationship. So it suggests maybe curiosity might help memory as we get older, fitting with this idea of selectivity in old age, that older adults selectively remember, what's of interest. And so in a more recent study, we've looked at different types of curiosity. Curiosity is a trait, and research tends to show that as we get older, I was surprised by this, this more general stable personality trait tends to decline with age, that older adults score lower on trait levels of personality tests of curiosity. But curiosity is a state. This is kind of the momentary interest in learning specific information, could lead to heightened motivation or engagement. Sometimes it leads to people just watching more YouTube videos. So you're like, oh, that was really cool. I want to watch the next video that's being offered in the next one. So this is more, a state-driven aspect of curiosity. And this might be something that actually might be very engaged in older adults with these trivia questions. So we were interested in curiosity across the lifespan. Do we get more or less curious with age? Does trait curiosity decline with age, which is prior work has shown? And then is curiosity almost more selective, kind of fitting with this value-directed remembering theme as we get older? And so this is work done by Mary Watley for her dissertation and recently published with other collaborators that have studied this as well. And so what we found, jumping to the results, and again, this is one of these standard mTurk samples. It's a large sample, but it is on mTurk, so that does qualify what group we are testing. But it's a nice age range from 20 to 84, and the results I think are really interesting. So first, in this trait measure of curiosity is measured with an epistemic curiosity scale. You find that this a linear trend of decline with age, and that fits with prior work as well that finds that trait curiosity tends to decline with age. But what I think is most interesting is this middle graph where you see this almost U-shaped function, and that what's happening, these are the average curiosity ratings given for each of these questions. You find that there's actually an increase as we get older. That as we get older, we tend to be more interested in some of these questions, and that might guide then our memory and what we later retrieve. And so it's fitted by this U-shaped function and partially by a linear function, both of which show some, I think, interesting trends after the age of 45, 50. And then this last graph just shows that the epistemic curiosity, the trait measure, is related to the state measure. So there's definitely some overlap there, as you might expect with this sort of work. So I think that's another interesting kind of thing that's happening as we get older, is we might show these, this intact or even heightened level of curiosity, which can be both good and bad. It might engage you more in learning, which is great. It might engage you more in, spending time on these rabbit hole videos or, reading excessively, but it can also potentially engage you in scams and fraud. So that's something we're interested in measuring now, because sometimes that's how, scams capture people's imagination or interest, and then all of a sudden people start making sense of something that they shouldn't be paying attention to. So that could be the dark side of curiosity potentially. Yeah, so that's one of the future directions, and I'll wrap up. That we're interested in subjective importance. So, at the beginning of the talk, I was talking about words paired with point values, and then the grocery prices, and then this curiosity, which I think is more subjective. But we also want to be careful where we put our curiosity and our attention. And I think as we get older adults might become more, an editor of their memory. That knowing you can't remember everything, you might then selectively remember things and maybe change things to make sure they fit like schemas. And another direction I think is interesting is social communication. So, I tell people, okay, imagine you missed this presentation, you missed, the 40 minutes of this talk. How would you then tell, someone else about this? So certainly you wouldn't spend 40 minutes giving them the exact transcription of it. You would summarize it. And I think summarizing is a really important thing that we can do, because it allows us to kind of focus on the important information. And I think as we get older and realize we can't remember as much, maybe that is an adaptive strategy. So I think, in terms of theory, this is, I don't know if this theory is specific memory selectivity theory, but I've been using it to guide this research to say, in any case where we're overloaded with information, when we're rushing, when we're busy, if we're effective, we'll engage in selectivity. And this selectivity involves choosing what is important and not highlighting the entire textbook, if you're studying for tests and exams. And I think, there's a variety of things that lead to value-directed remembering and reward-based processing. And I know people in the room study, decision-making, dopamine. I feel like at least for older adults, metacognition plays a very important role, because it allows us to know that if we can't remember everything, or if we've experienced memory errors, we know we need to kind of take our time, back up, make sure we're remembering the important things. So a colleague of mine shared this quote with me. It's a triumph of life that old people lose their memories of inessential things, though memory does not often fail with regards to the things that are of real interest to us. Cicero illustrated this with the stroke of a pen. No old man forgets where he's hidden his treasure. Although I'm not sure that explains why we're all constantly looking for where we put our keys or our phone. So with that, I will end and thank collaborators from my lab at UCLA and funding that supported this line of research. So if you're interested in further reading or articles, this is a very recent, short, selective article on memory selectivity in old age and current opinion. And then the book that I've talked about provides more of a background for this field of study. So I'll end with that. Thank you. Looking forward to some questions and comments. And if you don't have time to ask, please send me an email.
Thank you so much. That was a fantastic talk. So we'll go ahead and open the floor for questions. So you can either raise your hand, your virtual hand, you can type in the chat that you have a question, and we'll just ask you to unmute. Yeah, go ahead, Peter.
Thank you so much for a great talk. That was so generative. I had so many great ideas during it. So really appreciate that. I was curious about attention. I feel maybe I missed something. In some ways, it seemed like you were saying older adults had better metacognition. They're more selective, more strategic, and yet you also showed that they initially were worse at metacognition. And so I'm sitting here trying to put that together into one story about older adults and their metacognition, and I feel like I didn't quite get there. Can you help me see how that
it's a
comes
great
together?
question. Yeah. And I think, I think that's a good connection to make, because so some research shows that older adults' metacognition is intact. And, that's, I think, an overgeneralization. I think what's interesting about these value-based tasks is on the first list, older adults struggle, right? And they recall, 3 or 4 words, but not the high value ones all the time. What happens on later lists is their metacognition becomes more tuned. And I think that's because this is a lab-based task. They're not used to the task. They're like, how many words? And just like when I showed you, you might think, oh, I'll just remember all of them. And then you realize, wait, they went too quickly. Oh, I have to be more selective. And so I think in this task, older adults are learning, and that their metacognition then improves. In the real world, I think older adults know their memory is not working well. In fact, I know my memory is not working well. My wife tells me something, I'm like, I'm going to have to write that down, or I have a meeting tomorrow, I'm going to have to put a reminder in my calendar. So that's my metacognition reminding me of like, hey, don't just count on this automatically being encoded. So I think maybe that's the connection, is that older adults' metacognition can be intact. On these tasks, initially, it isn't, because, they don't know, how many words they can remember, or, why are we presenting 80 word pairs when we know they won't remember all of them? Whereas younger people might be like, hey, this is like a lecture where I'm not going to remember everything, and I'll just try and remember as much as I can. So I think that's the connection. But I think it's a good point that what do we mean by metacognition in these sorts of situations? And I think it's older adults do come to the table with a lot of concerns about their memory. They're thinking a lot about it. So when you put this task in front of them, they might initially just try and go for as many words as they can. But I think it's an effective strategy that they can say, oh, this is much like all these other situations where I can't remember everything. I better be selective. So
Do
hopefully
you
that
think you
connects
could
it.
eliminate that stumbling block with like instruction? Sort of
Oh,
saying,
yeah.
hey, listen, I know you're going to want to try to do everything,
Yeah.
but research has shown that you can't. So
Yes.
I really want you to try to pick and think about the
Yeah.
things that are really valuable. And like,
Yeah.
would
And
that allow
I
them to
think you
just
don't
like
even need
skip
to
that
say
part?
research has shown that you can't. You can just remind them you've shown that you can't. But we've done that very much with stereotype threat, or just having them read a little article about memory and aging, and you know how it declines, and you know how you're old, and how old are you? All of a sudden, it puts them under this stress, whether it's threat, I don't know. But then they're kind of selective very quickly. Yeah. And actually, we found a few other instances where if you rush younger people, like put them where it's speeded, and older people, they'll become selective too. And even divided attention, which you might think would impair this whole thing if it's kind of an attentional thing, under divided attention, you're selective. And you might have this experience where you have like a million things going on and kids yelling at you, and you haven't slept well. And you're like, you know what? I need to buckle down. I'm just going to focus on three things. So maybe those circumstances kind of engage that metacognitive approach.
Thank you so much.
Yeah.
Great. Jasmine?
Hello, thank you so much for the very interesting talk. Um, it's a very interesting field, and it's great to hear more about it. I was wondering, to what extent do people, and particularly older people, spontaneously engage in these strategies, and what do we know about the exact, precise strategies that people engage in overall? Because when it comes to like remembering, people can start rehearsing. They can like try to make a rhyme out of the words, or like use any other sort of strategy that makes it easier for them. Do we know anything about age differences there? And particularly considering that older people tend to have like an associative deficit, does that make a
Mhm.
difference?
Yeah, no, it's a great question. And certainly the strategies people use impact, memory performance. And a lot of older work has shown that younger people tend to use more effective or deeper levels of processing spontaneously. And,
Mhm.
if you look at students, that's what they're constantly doing. Like, how can I use images? And older adults don't do that as often for probably a variety of reasons. But what I think is interesting is the research has shown that when you give them these strategies, or say, use interactive imagery, they do much better. They don't catch up to the younger adults, but they do much better. So I think that's interesting to show that it's not that they can't do it, it's just not as spontaneous. And I remember instructing one older adult to do this, and they said, "Oh, that sounds like it's cheating," right? Like they
Mhm.
almost felt like, "Oh, memory is this thing where I see things and I remember them," right? That's kind of like memorizing things. Whereas I think college age students, and I think that's why there's some cohort differences here, are just so used to being like, what tricks can I use? Like I remember I memorized the entire periodic table, not
Mhm.
because I was good at chemistry, but I just made up a rhyme that, and the images and so on. And I
Mhm.
think that's like, to me, that's like extra memory, right? Like that's using something to trick your memory into remembering something you don't care about.
Yeah.
And older adults are probably like, that takes time and energy and it's weird. But we know that is an effective strategy. So I think, yes, it's tough in these experiments because it's like you either tell people what strategies to use or you don't, and then see which ones they use.
Mhm.
I think with this value-directed remembering task, people are like, okay, now I know which ones I need to remember. What should I do to remember them? You might think it's rote rehearsal, and sometimes it is at the beginning of the lists, but then I think people realize, hey, that's not very effective. And so, like I said, looking at the neuroimaging study, towards the end of the task, people say I used imagery, and it's funny that we need an fMRI to then confirm that they were indeed engaging, brain regions based on their self-reports. But I think that's really interesting to show that older adults can engage these, brain regions
Yeah.
to remember high-value information.
Yeah, it's interesting because older people have been young as well at some point, and particularly the ones that will come to laboratory probably have a higher degree of education. So they
Right.
probably have learned these strategies at some point, but
Yeah.
probably just don't engage in them as flexibly anymore.
I think that's a great point. And yeah, definitely. And so you're getting some cohort differences, but these older adults come to the table with a lot of stuff, right? Like a lot of knowledge, a lot of memory failures, a lot of, awareness of their memory. They're thinking a lot about it. And so I think when you give them a task like the grocery prices or the trivia, they love the trivia paradigm. Like that's
Mhm.
why we've been using it a lot too, is that, it engages them. They're good at forgetting the trivia they don't care about, and they're really good at remembering the ones they do, maybe because it overlaps with some marginal knowledge. But I think that was a really interesting way to engage older adults relative to these. I started with my master's thesis doing unrelated word pairs that really put older adults to sleep. Or in fact, again, anecdotally, some of these older adults would just see these unrelated word pairs and say, oh, those words don't go together. Like, which is like, it's like, yeah, but your job is to make some weird image to make them go together, which is exactly what the younger adults are doing, because that's how younger adults realize they can trick their memory almost.
Mhm. Thank you very much.
Great. Asaf?
Yes, great talk. Thank you. I'm wondering about the trait curiosity versus state curiosity differences that you found. And it sort of reminded me about distinctions in aging between explore and exploit. So the idea that older adults are less explorative and more exploitative in their cognition more broadly. And I'm wondering whether that, I don't know which one actually came first. Maybe they were first less explorative, and then they were less trait curious, or vice versa. But they do seem to be very related to one another, those concepts, in a way.
Yeah, I think you're right. And, I'm not a personality psychologist, so we really dabbled into this area of saying, we all think of curiosity as just unitary, but there's certainly people who who are very curious types. And then there's sometimes, ways you can engage specific types of curiosity. So I don't know the research exactly on, there's some research on like openness to experience for older adults and, how that might be engaging. So I don't know. To me, this is all very new. In fact, the state and trait are definitely correlated too. But I think, it's not like you should always be interested in everything, because that might not allow you to be focused. But there's probably people in this room. Mary Watley's here, I see. So she did the research. Maybe she has some insight. Matthias, I'm sure, knows probably more about this than I do. So maybe he has some insight that he wants to share as well.
Yeah, go ahead and jump in.
Yeah, I was wondering about that finding as well with the state effect, right? That the state effect, state curiosity for the trivia questions that increased with age. Could that be just a material effect? Because we always wonder about, okay, what are the right questions to use for our sample? If we use a developmental sample or a young adult sample, could this just be that the trivia questions used were just more engaging for the older adults? Or can you control for that somehow in your analysis?
Yeah, it's a great question. Let me see if I can find. We certainly see these trivia questions. I'm just going to jump out of the slides for a second. Older adults give higher ratings overall than younger adults, and I think it fits with like for younger adults, it probably feels like, oh, this is like undergraduate learning. It's not as engaging. So I think that's partly why we view these materials, as we know older adults, it gets them interested. I don't know what other materials we'd want to use for curiosity. So sometimes we've tried to use like, how interested are you in learning the translation of this word pair or general knowledge? We've normed these materials. Ko Moriyama's spent a lot of time norming them just to make sure that older adults don't know the answers or aren't closer, because if you're looking at memory, that could be an issue. But I think it's also a feature of these materials. So you might say, oh, this is the problem with the materials. And I'm thinking like, yeah, that's probably why we get some of these effects too. On the other hand, younger adults go to like pub nights to play trivia, right? Like it does engage people, and people play Trivial Pursuit. Like it's not just old people. But I've gone to seniors' homes, and trivia night is a big thing there. So there's something about the fun of retrieving something from semantic memory. I wonder if there's a dopamine component. Might have like the dopamine story to me is very interesting because it seems to suggest that wouldn't be guiding older adults at all because there's declines in it. But maybe this is the sort of thing that just gives a little bit of a boost because it's like, hey, this is something I should know or might know. And maybe there's a social component too, like, hey, because we've also tried to now do this with how likely would you share this information with someone else? And it's funny because when I say share, most young people think share on social media, but older people think share like, oh, I'll tell my grandkids or my spouse. Like, I'm not interested in baseball, but I know my grandson would love to know about this. So there's probably a variety of things that guide it. But yeah, I think the materials play a big role in the effect. So I'd love to see if you could replicate this with other sorts of materials or tasks. Yeah.
It's really interesting to hear about the social component. We actually just had a discussion with a collaborator, Pierre-Yves Oudeye, who doesn't use trivia questions to stimulate curiosity, who made the point actually trivia questions, they're actually sometimes not that engaging. It's just the social component. We go to trivia nights because or to pub quizzes because it's fun, right? To wonder about the question, about the answers with our friends. So whether actually the social component in your older adult sample might play a bigger role, as you said.
It'd be really interesting. I don't know if you could test people in groups, but I think you're right. Like no one would online play trivia, but they go to pub nights. But maybe I've wanted to also ask people like, okay, so we just show you this bit of trivia. How interested would you be in watching a 2-minute YouTube video about this now? And like, does that then manifest in behavior of like, actually that stimulated, I never thought of bird migration until this question came up. I'd watch a little bit more about that. So both social communication, but also like engagement. Yeah.
Super interesting. Thank you so much
Okay,
for
I
the
think
talk, Ellen.
we're running out of time, but we could do one last question, maybe Sebastian, if it's quick.
Yeah, or maybe we can do two if you're fine with that. Then yeah. I super interesting overview. Thanks so much. I wondered, coming from this selection optimization compensation theory, some have argued there's different types of selectivity, like elective selectivity, where you could argue it's more preferential. People could, in principle, pursue another course of action, but they have different preferences. But then there's also this idea of loss-based selection because of declining cognitive resources, for example. You are forced to be more selective. I just wondered how you think about this in this value-directed remembering paradigm, because I wondered, on the one side, you could imagine the task is relatively harder for older adults. So there is definitely this loss-based component there. Do you think the reason they are not even more selective is that maybe these selection strategies themselves are maybe also requiring some kind of cognitive control or attention?
Yeah. No, it's a great question. I think it is a little bit resource demanding, and we know cognitive control declines with age. So I think older adults, it's hard for them to then realize, oh, ignore this. And that's probably why we see declines with Alzheimer's disease. The gain versus loss is a really interesting angle. We've, tried to look at this a little bit in terms of you're collecting points versus you're going to lose points if you don't recall. And that really hurts older adults. Maybe it's just more stressful, like, oh, not only is my memory being tested, but I'm going to lose if I don't recall the high value ones. So they don't like that as much. So maybe that gets at the gain versus loss. We've done it with faces paired with money that you either get if you remember the face or you lose. So it's like some faces owe you money and some faces you owe money to. And we find this interesting dissociation that older adults remember the faces that owe them money, but they don't remember the faces they owe money to. Which I don't know if that's a strategic thing. Like, look, I need to collect from the people that otherwise they won't pay me. Whereas if I owe someone money, they'll find me. I don't know. But I thought that was really interesting. So I don't know if that gets at your gain versus loss. I think you're also right about the resources that it does require. Maybe that's why the first few lists older adults are really struggling, because it's like, oh, I have to not only use my memory, but I have to monitor and think what's high value and so, yeah, it'd be interesting to look at that more in terms of, situations where maybe there's more support early on for older adults.
Thank you.
Okay, I think we'll end it there. People can check out the chat before heading out, but I think for the sake of time, we'll go ahead and end it there. And thank you so much, Dr. Castel. That was a fantastic talk. And we will be back. The meetings will be back next year in 2026. We already have some scheduled, but I think coming in January, we'll at least have kind of a schedule for the following semester. So if people can be on the lookout for that, that would be wonderful. All right. Thank you.
Thank you.